Right now, somewhere in the night sky above Australia, a star is about to explode. Not in a million years, not in 1,000 years. Right now. Any night, it could be tonight, it could be next week, it could be next month. A star that has been completely invisible to the naked eye for the past 80 years is going to suddenly appear out of nowhere and become one of the brightest objects in the sky. The last person to see this with their own eyes was alive in 1946. Before that, you'd have to go back to 1866, and before that, 1217. A medieval monk recorded it as a wonderful sign that shone with great light for many days. And now, mate, it's our turn. This is not a theory. This is not speculation. Scientists around the world are watching this star right now, waiting. They have been watching it for years. And tonight I'm going to tell you exactly what it is, exactly why it happens, and exactly how you can step outside and see it from your own backyard in Australia. No telescope required. If you want to be one of the first Aussies to know the exact moment this happens, subscribe right now and turn on notifications. We will cover this the second it occurs. Now, let's get into it. The star we're talking about is called T Coronae Borealis. Scientists call it TCRB for short. Its nickname, and I love this, is the Blaze Star. It sits about 3,000 light-years from Earth, tucked inside a small constellation called Coronae Borealis, the Northern Crown. It's a modest, unremarkable-looking patch of sky on any normal night. Now here's where it gets really interesting. TCRB is not just one star. It's actually two stars locked in a gravitational dance with each other, orbiting one another every 228 days. One of them is a red giant, a massive, bloated, dying star that has swelled to hundreds of times the size of our Sun as it enters the final stages of its life. Think of it as an old star burning through its last reserves of fuel, growing larger and more unstable as it goes. The other star is a white dwarf, and this is the troublemaker. A white dwarf is what's left behind when a star like our Sun dies. The core collapses, the outer layers get expelled, and what remains is this incredibly dense, incredibly hot object roughly the size of Earth but with the mass of our entire Sun. It is, without exaggeration, one of the most extreme objects in the known universe. And what happens between these two is basically cosmic theft on a massive scale. The red giant is slowly shedding its outer layers into space. The white dwarf, sitting right next door, is pulling that material in with its powerful gravity, collecting it on its surface layer by layer, decade by decade, century by century, just waiting. And then, after all those decades of stolen material building up on its surface, the white dwarf reaches a critical threshold. The pressure and temperature become so extreme, so unimaginably intense, that it triggers a thermonuclear explosion right on the star's surface. A runaway nuclear chain reaction that ignites in a fraction of a second and blasts that stolen material outward into space in a colossal flash of light and energy. This is what scientists call a nova, from the Latin word for new, because to ancient astronomers it looked like a brand new star had appeared in the sky. And that is exactly what it will look like to you and me when it happens. A new star, appearing out of nowhere, visible to the naked eye. Now here's the part that makes TCRB different from most novae. It's what's called a recurrent nova, meaning this is not the first time it has done this. The white dwarf doesn't get completely destroyed in the explosion. The core survives, and then the whole process starts again. Steel material, build up, explode, repeat, over and over. Every 80 years or so, like a cosmic clock that has been running for thousands of years. 1,217, 1,787, 1,866, 1,946. Each time, someone on Earth looked up and saw a new star appear out of nowhere. Each time, they had no idea what they were looking at. And now, 2026, we do. We have the science. We have the data. We watched the exact same warning signs that appeared before the 1946 explosion. The star dimmed, exactly like it did 1 year before it blew. Then it started brightening again. That is the trigger. The explosion is coming, and it could happen any night now. So what will actually happen when it goes off? Right now, T Coronae Borealis is completely invisible to the naked eye. You'd need a reasonably powerful telescope just to spot it. But when it explodes, and this happens fast, within just a few hours of the nuclear ignition, it will brighten by a factor of roughly 1,500. In the space of one night, it will go from invisible to being clearly visible with no equipment whatsoever. Scientists expect it to reach roughly magnitude 2 in brightness, about as bright as Polaris, the North Star, and comparable to some of the brightest stars you can see on any clear night. Bright enough to see clearly from the middle of Sydney or Melbourne despite all the city lights. Bright enough that someone who has never looked at the night sky in their life will notice something new up there and wonder what it is. Now, here is the part that makes this especially important if you're watching from Australia. And this is something that most videos about TCRB completely ignore, because they're made by people in the Northern Hemisphere. So let me give you the Australian-specific guide right now. Corona Borealis sits in the northern part of the sky. From Australia, this means it appears lower on the horizon than it would for viewers in Europe or North America, but it is absolutely, clearly visible from anywhere on the Australian continent. You just need to know when and where to look. Face north. Find the bright orange star Arcturus. It's one of the 3 or 4 brightest stars in the sky and very easy to spot. Once you've got Arcturus, look slightly to its right and a little higher. You'll see a small, neat, semicircular arc of fainter stars. 7 of them, curving gently like a crown. That's Corona Borealis. When TCRB explodes, a new star will appear right in the gap in the middle of that arc, as if someone placed a bright jewel into the crown. The best time to look is between 10 p.m. and midnight in the months between April and September. That's when Corona Borealis is highest in the northern sky from Australia. The further north you are, Queensland, the Northern Territory, the Kimberley region, the higher and more clearly it will appear. But even from Hobart in Tasmania, on a clear night with no clouds on the northern horizon, you will see it without any trouble at all. My recommendation, download the free app Stellarium on your phone right now. Open it, point it north, and find Corona Borealis. Familiarize yourself with exactly what it looks like tonight, with no new star. That way, the moment TCRB explodes, you will immediately notice the difference. You'll step outside one night, look north, and there it will be. A star that wasn't there yesterday. Now here's something that most videos about this event don't talk about, and I reckon it's actually the most fascinating part. When TCRB explodes, it's not just a pretty light show. It is one of the most valuable scientific events of the decade. Astronomers around the world have been preparing for this moment for years, and the moment it goes off, an enormous amount of scientific equipment is going to be pointed straight at it. The James Webb Space Telescope will observe it. The Hubble will observe it. Ground-based observatories on every continent, including right here in Australia at the Anglo-Australian Observatory in New South Wales, will be watching. Because a nova explosion of this kind, this close to Earth, this well predicted in advance, is extraordinarily rare. It gives scientists a chance to study the mechanics of thermonuclear explosions in real time, in incredible detail. What they learned from TCRB could help us better understand how elements are forged and dispersed through the galaxy. Some of the atoms in your body, the calcium in your bones, the iron in your blood, were created in explosions just like this one, billions of years ago. When TCRB explodes, it is not just putting on a show, it is doing what stars have done for 13 billion years, creating and scattering the building blocks of everything that exists. I want you to think about something before we finish. The light from this explosion, the light that's going to travel 3,000 light years across space and arrive at your eyes in your backyard. That light left the star 3,000 years ago. It has been traveling through the void of space since before the Roman Empire existed, since before the birth of democracy in ancient Greece, since the time of King Solomon. In 1946, a soldier returning home from World War II may have stepped outside one night and noticed a new star in the sky, not knowing what it was. In 1866, a gold miner in the Victorian goldfields may have looked up from his campfire and seen a strange new light appear overhead. And in 1217, somewhere in medieval Europe, a monk looked up at the night sky and called it a miracle. We know what it is. We have the physics. We have the mathematics. We have the telescopes. We can predict it, explain it, measure it. And yet, standing in your backyard on a clear Australian night, looking north and seeing a star appear out of nowhere that wasn't there the night before. I reckon that feeling of wonder is going to be exactly the same as it was for every single person who has ever seen this. In 1217 or in 2026, a new light in the sky is a new light in the sky. And that, mate, is something worth stepping outside for.